Right now, 45 billion kilometers from where you are sitting, a machine older than most of your parents is running out of power, and the people watching over it just admitted something they have been avoiding saying out loud for years. Every single message Voyager 2 sends back to Earth could be its last one. Not someday, not eventually. Right now, today, this exact message could be the final one we ever receive from the most distant human-made object in the history of our species. That is not a scary headline invented for clicks. That is an actual quote from a NASA scientist working on this exact mission, and once you understand why they are saying it, the whole story becomes far more emotional than any fictional doomsday video could ever be. Let's rewind for a second because most people have completely forgotten just how old this spacecraft really is. Voyager 2 launched in 1977 before most people alive today were even born, riding a wave of ambition that NASA itself only expected to last 5 years. Its job was simple on paper: fly past Jupiter and Saturn, take some pictures, and gather some data, then quietly fade into the background like every other mission before it. Nobody, not one single engineer on that original team, expected this tiny machine to still be talking to us nearly 50 years later. Yet here we are, and Voyager 2 has become the only spacecraft in human history to fly past all 4 of the outer giant planets: Jupiter, Saturn, Uranus, and Neptune, giving humanity our first ever close-up look at 2 of those worlds that we still have never revisited since. Think specifically about Uranus and Neptune for a moment, because this detail tends to get lost in the excitement of the bigger story. Voyager 2 remains, to this very day, the only spacecraft in the entire history of space exploration to have ever flown close enough to either of those 2 ice giants to capture detailed images and readings. Every photograph most people have ever seen of Uranus's pale blue-green surface, every measurement of Neptune's wild storms and its strange, backwards orbiting moon Triton came from this single spacecraft during flybys that happened decades ago. No other mission, from any country, has gone back since. If you want to see either of those planets up close today, the only real option scientists have is to pull up the exact same dataset Voyager 2 gathered during those flybys in the 1980s, because nothing newer currently exists. That fact alone should put into perspective just how much irreplaceable value is still riding on this one aging spacecraft. It is not simply a nostalgic old machine drifting through space for sentimental reasons. It is currently the single source of certain kinds of information about our own solar system that no other instrument, anywhere, has ever managed to replace. After finishing that planetary tour, Voyager 2 kept going, pushing further and further from the Sun, past the orbit of Pluto, past the edge of where our solar system's magnetic bubble even ends. In December 2018, it officially crossed into interstellar space, becoming only the second human-made object ever to leave the protective bubble the Sun creates around our entire solar system, joining its twin, Voyager 1, in a region of the universe no other machine built by human hands has ever touched. Think about that phrase for a second. Interstellar space. This tiny spacecraft, built with less computing power than the calculator sitting in your phone's calendar app, is currently drifting through the actual space between stars. But here is the part almost nobody talks about, and it is the real reason this story matters right now. Voyager 2 does not run on solar panels. Out where it is flying, sunlight is far too weak and far too distant to power anything useful. Instead, it runs on something called a radioisotope thermoelectric generator, a device that converts heat from slowly decaying plutonium into usable electricity. When Voyager 2 launched, that system produced around 470 watts of power, roughly enough to run a couple of household appliances. But radioactive decay does not care about our timelines or our hopes. Every single year, without exception, Voyager 2 loses about 4 watts of usable power, a slow, steady, unstoppable countdown that has been ticking since the day it left Earth. To put that decay rate into perspective, imagine a battery that started with roughly 470 watts back in 1977, enough to comfortably run several household light bulbs and a small appliance or 2 at the same time. Now imagine that same battery slowly draining, not because anything is broken, but simply because the radioactive plutonium powering it naturally weakens over time, the same way any radioactive material gradually loses its potency the longer it exists. There's no way to recharge it. There's no way to replace it. Once that plutonium's heat output drops below what the spacecraft's instruments need to function, those instruments simply stop working permanently, with absolutely no way for engineers back on Earth to fix it from this distance. Every watt saved by turning off one instrument becomes a watt available to keep another instrument alive just a little bit longer, which is precisely why these shutdown decisions get debated so carefully before anyone commits to them. For decades, that slow decline was manageable. Engineers simply turned off equipment the spacecraft no longer needed, like the cameras that had already photographed every planet it would ever fly past. But eventually, the easy cuts ran out. What remained were the actual scientific instruments, the tools that make this mission scientifically priceless in the first place, since nothing else humanity has ever built is out there collecting this kind of data. In October 2024, NASA made a decision that quietly marked a turning point in this story. Engineers sent a command across billions of kilometers of empty space to switch off Voyager 2's plasma science instrument, the tool that had been measuring the flow of charged particles streaming past the spacecraft. That command took 19 hours just to reach the spacecraft, and another 19 hours for confirmation to come back. A delay so enormous it is almost impossible to picture. Imagine sending a message and waiting nearly 2 full days just to know if it arrived. That is daily reality for anyone working on this mission. Then in March 2025, another instrument went dark, the Low-Energy Charged Particle Detector, a tool that had been tracking ions, electrons, and cosmic rays streaming in from both our own solar system and the wider galaxy beyond it. The mission's own project manager put it bluntly at the time, saying that without these shutdowns, the spacecraft might have only had a few more months of power left before engineers would be forced to declare the entire mission officially over. Read that again? A few more months. That is how close this genuinely came to ending completely, and how directly these difficult decisions are the only reason Voyager 2 is still talking to us today. By early 2026, the same story played out again, this time with a cosmic ray subsystem scheduled for shutdown following an identical decision already made for its twin spacecraft, Voyager 1, just months earlier. Each of these shutdowns follows the exact same brutal logic. Every instrument left running drains precious watts that the spacecraft simply does not have anymore. Turn one more thing off, and the whole machine buys itself another year, maybe 2, before the next impossible decision has to be made all over again. Here's what makes this so emotionally different from a normal engineering story. These are not broken parts being replaced. These are working, functioning scientific instruments, still collecting genuinely unique data from a region of space no other machine has ever explored, being deliberately switched off while they still work, purely because there simply is not enough electricity left to keep everything running at once. Every shutdown is a small, quiet funeral for a piece of a machine that took human beings decades to build and send this far. NASA's own mission scientist, Linda Spilker, described the situation in words that have stuck with people across the entire space community. She said that every minute of every day, the Voyagers are exploring a region where no spacecraft has ever gone before. And that also means every single day could be their last. That is not exaggeration for a headline. That is the honest operating reality for a team of engineers who genuinely do not know, from one communication window to the next, whether the signal they just received will be the final one their instruments ever pick up. So why do people fear this moment so much? It is not really about losing a machine. It is about losing our only physical connection to a part of the universe we can currently reach no other way. Voyager 2 and its twin are literally the only human-made objects that have ever traveled into true interstellar space, and building a replacement is nowhere close to simple. There is currently no mission actively flying toward interstellar space to take over where the Voyagers leave off. When these two spacecraft finally go silent, whether that happens next year or sometime in the 2030s, as engineers currently hope, humanity will have no working eyes and ears in interstellar space at all, for however long it takes to design, build, fund, and launch something new capable of making that same multi-decade journey all over again. And that gap could be enormous. Space missions capable of reaching interstellar distances take years just to plan, additional years to build, and then decades of actual flight time before they reach anywhere close to where Voyager 2 already sits today. Realistically, if the Voyagers go dark before a genuine successor is already on its way, humanity could face a silence in this part of space, lasting for multiple decades, an entire gap in our direct exploration of the region just beyond our own solar system's protective boundary. Some scientists have floated early concept ideas for a future interstellar probe designed specifically to travel faster and gather even more detailed data than the Voyagers ever could, sometimes discussed under names like an interstellar probe mission concept. But even in the most optimistic timelines discussed by researchers, a mission like that would likely take many years just to receive funding and formal approval, additional years to actually design and build, and then decades of flight time before it reaches anywhere close to the distances Voyager 2 has already covered. Nothing currently exists that is funded, built, and already flying toward that same region of space. Right now, at this exact moment, the two Voyager spacecraft remain completely irreplaceable, not because nobody has thought about building a successor, but because nothing else has actually gotten far enough along to take over the moment they finally stop transmitting. Despite all of this, it is important to say clearly that Voyager 2 has not actually gone silent yet. As of the most recent updates from mission engineers, the spacecraft is still transmitting, still operating a handful of instruments, and the team's current power planning suggests it should be able to keep at least one instrument running into the early 2030s if nothing unexpected goes wrong. Engineers have already pulled off several clever tricks to buy extra time, including tapping into a small reserve of backup power originally built into a voltage regulation safety system, a move that alone delayed one shutdown by an entire extra year. NASA has even discussed a strategy nicknamed among the team as swapping several instruments off at the exact same moment in a single larger, power-saving move, rather than shutting things down one at a time, to squeeze every last bit of useful science out of the spacecraft before power finally runs too low to continue at all. That last part matters enormously because it shows this is not simply a slow, sad decline with nothing left to learn. Every single watt of power still flowing through Voyager 2 right now is being used to gather information that literally cannot be collected any other way on Earth or anywhere closer to home. Its remaining instruments continue measuring the magnetic fields and plasma waves of interstellar space, giving scientists an ongoing, real-time picture of an environment we have never had direct access to before in the entire history of our species. Every scrap of data beamed back across billions of kilometers adds another small piece to a picture of the universe that would otherwise remain completely theoretical, built only from distant telescope observations, rather than actual measurements taken by a machine physically present in that environment. There's also something genuinely humbling in just how far the signal has to travel. Voyager 2 currently sits roughly 20 billion kilometers from Earth, so far away that its radio signal, traveling at the speed of light, the fastest anything in the universe can move, still takes nearly 19 hours to reach our planet. When you watch a live video call with someone on the other side of the world, the delay is a fraction of a second. Voyager 2 signal takes the better part of an entire day to complete a single one-way trip. Engineers do not get instant feedback when something goes wrong. They send a command, then wait an entire day just to find out if it worked. A level of patience that most modern technology has trained us to forget is even possible. Communicating with something that far away also requires some of the largest, most sensitive radio equipment ever built. NASA relies on a network of giant dish antennas spread across different continents, working together around the clock so that as the Earth rotates, at least one dish is always pointed toward wherever Voyager 2 happens to be in the sky at that moment. These antennas were originally built decades ago specifically to keep talking to the Voyager missions and other deep space probes, and keeping this aging hardware fully operational is itself an ongoing engineering challenge, running in parallel with the power problems on board the spacecraft. There was even a moment a few years back when a single wrong command sent to Voyager 2 accidentally pointed its antenna slightly away from Earth, cutting off communication entirely for several tense weeks. Engineers on the ground had no way to simply call up and ask what went wrong. All they could do was send a signal, a faint whisper across billions of kilometers, and hope that whatever was left of the spacecraft's onboard systems happened to be pointed in roughly the right direction to receive it. Remarkably, it worked, and communication was restored, but that entire episode was a small preview of exactly the kind of silence engineers now know is coming permanently, sooner or later, whether from a technical glitch or simply from power finally running out for good. So, what actually happens when Voyager 2 finally does run out of usable power for good? Based on everything engineers currently understand, the spacecraft will not explode, crash, or suffer some dramatic mechanical failure. It will simply, quietly, stop being able to power its radio transmitter, and the signal we have been receiving for nearly 50 years will simply cut off midstream with no dramatic final message, no countdown, and likely very little advance warning beyond the ongoing power calculations engineers are already tracking closely. After that moment, Voyager 2 will not stop existing. It will keep drifting, silently, forever, carrying its famous golden record, engraved with sounds and images meant to represent humanity to any other form of life that might one day encounter it, long after every person currently alive on Earth has passed away. That golden record is worth pausing on for a moment, because it adds an entirely different emotional layer to this whole story. Long before anyone worried about power levels or instrument shutdowns, engineers in the 1970s attached a physical record to both Voyager spacecraft, containing greetings in dozens of languages, recordings of nature, and pieces of music meant to give any future finder a small glimpse of what life on Earth once looked and sounded like. Once Voyager 2 finally goes silent, that record does not go silent with it. It will simply keep traveling. A genuine physical time capsule launched by human beings, continuing to drift through the galaxy for what could realistically be millions of years into the future, long after the spacecraft itself stops sending us anything at all. The record itself is a genuinely remarkable object once you look closely at what it actually contains. Engineers and scientists, led at the time by astronomer Carl Sagan, spent months carefully selecting what should represent all of humanity to whoever or whatever might eventually find it. They included spoken greetings recorded in dozens of different human languages, ranging from formal statements to a simple child's voice saying hello. They included natural sounds recorded here on Earth, things like wind, thunder, birdsong, and ocean waves, alongside recordings of human activity such as laughter, footsteps, and the sound of a heartbeat. They included a carefully chosen selection of music, spanning different cultures and different centuries, packed onto a single physical disc, small enough to hold in one hand. Alongside the audio, the record includes over 100 images encoded directly into its grooves, showing everything from diagrams of basic mathematics and chemistry to photographs of human anatomy, family life, cities, farms, and landscapes from around the world. Instructions for how to actually play the record were even etched directly onto its cover in a kind of universal diagram, using basic physics and chemistry that any sufficiently advanced civilization, wherever they might come from, should theoretically be able to decode without ever needing a translator or a manual written in any human language. Nobody who worked on that record ever expected it to be found quickly, or perhaps ever at all. It was built as a message in a bottle thrown into the largest ocean imaginable, sent out with essentially zero expectation of a reply, purely as a gesture, a quiet statement that humanity existed, thought carefully about how to represent itself, and wanted some small piece of that identity to survive far longer than any single human life, any single nation, or possibly even our species itself. So, when people say Voyager 2's eventual silence confirms something we all feared, this is really what they mean, once you strip away the exaggeration. It confirms that even humanity's greatest engineering achievements are not permanent. It confirms that the physical laws governing radioactive decay do not bend for sentimental reasons, no matter how much we might want a 50-year-old machine to somehow keep running forever. And it confirms that right now, in this exact moment, we are living through the final working years of the only physical exploration humanity has ever conducted beyond the edge of our own solar system, with nothing currently built and ready to immediately take its place once it finally goes quiet. None of that means the story is finished yet. Voyager 2 is still out there right now, still transmitting, still collecting real data from a part of the universe we have never explored any other way. Every additional month it keeps running is a genuine bonus, squeezed out by careful engineering decisions made by a small, dedicated team who refuse to let this mission end a single day earlier than it absolutely has to. But the honest, unavoidable truth sitting underneath all of this is simple. The clock has been running since 1977, it cannot be reset, and at some point, whether that happens next year or sometime in the early 2030s, the very last signal will arrive. And after that, for the first time in almost 50 years, humanity will have no direct voice speaking to us from beyond the edge of our own solar system. If this story genuinely moved you, that is exactly the point of telling it honestly, instead of exaggerating it into something it is not. The real Voyager 2 story does not need a fictional twist to feel enormous. A machine built before most of us were born, still drifting through interstellar space today, still fighting to send us one more signal before its power finally runs out, is already one of the most quietly incredible achievements in the entire history of human exploration. Subscribe if you want to be here for every real update as this final chapter continues to unfold, because whenever that last signal finally does arrive, it deserves to be remembered accurately for exactly how remarkable it actually was. Consider just how strange this moment in time really is. Right now, while you're watching this, a message that took 19 hours to travel from Earth might be arriving at Voyager 2 at this exact second, and a reply sent back might not reach mission control until sometime tomorrow. That kind of delay barely feels real in a world where video calls connect instantly across oceans, yet somewhere out past the edge of our solar system's protective bubble, a 50-year-old machine running on power weaker than a household light bulb is still faithfully doing its job, still pointing its antenna back toward a tiny blue dot it left behind nearly half a century ago, waiting patiently for whatever instruction comes next. Nobody currently knows the exact date this story finally ends. It might be next year. It might genuinely stretch into the early 2030s if the team's careful power planning holds up as well as they hope. What is certain is that the number of remaining working years is now small enough to count, rather than something comfortably distant enough to ignore. That shift, from an abstract someday to an actual approaching countdown, is exactly why this story feels different now than it did even just a few years ago, and exactly why so many people are suddenly paying close attention to a spacecraft most of them had honestly forgotten was even still out there. It also says something about the team of engineers still working this mission every single day, most of whom were not even born when Voyager 2 first launched in 1977. They inherited a machine built by an earlier generation, using computing technology that feels almost primitive by today's standards. They have spent years finding clever, creative ways to squeeze every remaining bit of science out of it before its power finally runs dry. That kind of quiet, dedicated persistence rarely makes headlines, but it is the entire reason Voyager 2 is still transmitting today instead of having gone silent years ago. Whatever the final signal ends up looking like, whenever it finally arrives, it will be the product of decades of careful decisions made by people determined not to let this remarkable machine go quiet a single day sooner than absolutely necessary.